பார்த்தோம். ஸோ லைக் ஐ செட் லாஸ்ட் டைம், இன்னைக்கு நம்ம டெரிவேட்டிவ்ஸ் பற்றி பார்க்க போகிறோம். ஓகே, டெரிவேட்டிவ்ஸ் இஸ் நத்திங் பட் டிஃபரன்ஷியேஷன். டெரிவேட்டிவ் கண்டுபிடிக்கிற ப்ராசஸ்க்கு பேர் டிஃபரன்ஷியேஷன் அப்படின்னு பேர். ஸோ டிஃபரன்ஷியேஷன் வாட் யூ கெட் இஸ் த டெரிவேட்டிவ். ஓகே, இப்போ டெரிவேட்டிவ் அப்படின்னா என்ன அப்படின்னு ஃபர்ஸ்ட் நம்ம பார்ப்போம். டெரிவேட்டிவ் அப்படின்னா ஐ ஷேர் மை window now. Derivatives. I think you are all screen பார்க்க முடியுது இல்லையா?
Yes sir. Yes sir.
Yeah, okay, okay. இப்போ derivatives அப்படின்னா it is nothing but rate of change. Okay, so if suppose a function is given, okay, y equal to f of x, suppose there is a function that is given to you. So what is the rate at which it is changing at every point? So it will vary, right? It may vary. From inge or rate of change will be something else, inge rate of change will be something. Rate of change abdina enna? So change in the dependent variable corresponding to the change in the independent variable. When independent variable changes by a small amount, by how much does the dependent variable changes? The y is the dependent variable, x is the independent variable. Suppose y equal to f of x. Okay, so rate of change or derivative, we represent it as y prime. Okay, or dy dx. This is a symbol that we use for derivative. Okay, so derivative is defined as change in the dependent variable by change in independent variable. Okay, by what is the rate of change of the dependent variable when independent variable changes, that is delta y divided by delta x. Okay, now what is delta y? Suppose here, what is the change? So this is where delta y, this is where delta x. So by when x changes by a small amount, how much does y change? And it will depend on the value of delta x. The most accurate value will be when delta x is very small. Exact on the point rate of change delta x has to be very small. We have to take delta x tending to 0. So upper the limit of this delta y by delta x, limit of delta x tending to 0, delta y by delta x. Okay, so we simply put delta y by delta x, but the better definition would be exactly at a particular point. We have to take it as delta when limit when delta x tending to 0. So now what is delta y? What is the change when x changes from say some x0 to something x0 plus delta x, right? So it is the f of x0 in the point and x0. Okay, in the point of the x0. Okay, so now f dash of x0 at that point is equal to limit of delta x tending to 0 delta yன்றது f of x0 plus delta x minus f of x0. So this is your delta x. So obviously here the x value is going to be x0 plus delta x. So this point y value is going to be f of del x0 plus delta x. So adana f of x0 plus delta x minus f of x0. F of x0 da in the point. So in the delta y is given by f of x0 plus delta x minus f of x0. That whole thing divided by delta x as delta x tending to 0. So idathaan nama derivative adin solra. Okay, so basic principle of derivative idha. Okay, so idu romba useful namaku eppdina suppose we know that velocity equal to rate of change of motion or displacement. Velocity equal to rate of change of displacement. Okay, but suppose the displacement is a curve. Okay, suppose the body is accelerating or decelerating. Okay, the displacement may be like a curve like this. Okay, so this is your displacement at any point in time. This is time versus displacement. So at any point in time, suppose we want to find out the velocity. So how can we find out? The only way is, rate of change of y with respect to x, or here rate of change of displacement with respect to time at this particular point. We have to use the same formula that we just now saw. Okay, and what is that? Suppose this is your t0 time at time t0 minute. No? So this is your displacement is y. Okay, so this is your y0. So same principle that we apply. So velocity at t0 is given by f of t0 plus delta t. So what we have to do is take a small amount of time, additional time, okay, and see how much additional distance it goes. So that will be f of t0 plus delta t. So that is, we have to subtract from that original y value, which is f of t0.
Raja, sorry for interruption. I think 1 or 2 students are waiting. Kunja admit panna. Paranga. Yes, come.
Yeah. All right. So this is the only way in which we can determine the exact velocity at point t0 or at time t0. So for that we need the differentiation function. So this velocity at t0 is given by f of t0 plus delta t minus f of t0 by delta t when delta t tends to 0. So now velocity is something that we practically use, in many situations or many problems. So, but that velocity is given by, suppose, distance is not a linear function. So then we have to differentiate to find out what is the velocity at, any point in time. For example, a free falling body. So it is not going to have it will have acceleration. To find out the velocity at any point in time, we need to use this formula, limit delta tending to 0, whatever that we just now saw. So this is the basic, this is called the basic method of getting the derivatives. This is the formula. F of, we generally say f of, we denote it as, like I said, f dash of x, okay, or f prime, okay, equal to now f of x plus h minus f of x divided by h when h tends to 0. Okay, so now let's do a few problems. Okay, noted a few problems. So if we want to find out the derivative at any particular point x0, we can also use this is one formula, f of x0 plus h minus f of x divided by h. The other way also is equal to limit x tending to x0 f of 0 minus x, sorry, plus x, 0 minus x, sorry, of x minus f of 0 divided by x minus x. So this is the another formula that we can use. Okay. So they are equivalent. Okay. Now let's do a few problems. Find the derivatives. The basic. Now, basic principles. Okay. So let us say f of x equal to a constant like 5. Okay. So what will the function look like?
Constant function.
Okay, this is the function. Okay. So from this, can you see by how much y is changing when x is changing by a certain amount? If you take this place, no? If x is changing by a small amount, how much y is changing?
5.
Y is not at all changing. It was 5. Even when x changes to something else, suppose x was 5, at that time y was 5. When x became 6, still y is always 5. Yes, it's a constant function. Y doesn't change at all. So here the rate of change of y with respect to x is going to be 0, right? It is not changing, right? Y is not at all changing. Y is constant. Y is right?
Yes, sir.
Yes, sir.
Okay. Now let's see how we get it from the first principles. Okay. So f of x equal to 5. So what is f dash of x? We saw that limit h tending to 0 f of x plus h minus f of x divided by h. Now try to substitute. So since f of x is 5, what is f of x plus h? So for whatever values of x, it is going to remain 5. Yeah, and f of x plus h will also be 5 minus f of x is 5.
5.
Yeah, divided by h.
H
comes to 0. So
0.
we can see it from the graph also, but and this is the way we get it from the first principles. Okay. So for any constant, the derivative is 0. Now let's take another little more complicated. Okay. Now f of x. So now f of x is given as 4x plus 6. Now for each unit of x, how much does y change?
4x.
Correct. X equal to 0, y is minus 6. This is 1 point. When x equal to 1, becomes minus 2, somewhere here. Right? When x equal to 2, it becomes 4 and 8 minus 6 plus 2. So it goes something like this. So at any point in time, when let us say some point, when x changes by 1 unit, so how much does y change? It is given by this tan theta. Right?
2 units.
It will be 4 units actually. For every time x change, x be increased by x by 1, y increases 4 times. 4 by 4. Okay. So we can see from this chart also that dy by dx is 4 prime x. Now let's try to get it from the first principles. F prime x equal to f of plus h what is f of x plus h? 4, you put x plus h in place of x, yeah, 4 into x plus h. Minus 6. This is where f of x plus h. Minus f of x. Whole divided by h. You will put limit, right? We simplify it. 4x.
4x plus 4h.
Yes.
Minus 6.
Minus 4x.
Minus 4x plus 6.
Right.
Sir, 4h by
Yeah. Well, the 4x cancel out. Yeah. So what remains is
4.
this.
4.
3x, sir.
Yeah. Limit h tending to 0, 4. So it is equal to 4. Right. So that is your f prime x or dy dx. Let's do another problem. In this problem, I think நீங்களே போட்டுடலாம். Try to find its derivative using first principles. Try it out. Okay. నాదేదే నాకు స్టెప్ లిమిట్ h tending to 0 x f of x plus h minus f of divided by h. So you have to substitute. Tell me what will happen if you substitute here?
Double x square plus 2x.
Yes. Sorry. X plus h whole square. I think somebody is waiting.
2x.
Yes. Fine. X plus h the whole square plus 2 is your f of x plus h, correct? Minus f of x is x square whole divided by h. So what is the step in that?
X square plus h square plus 2xh plus 2
2x
minus x square minus 2.
Sir, answer 2x plus h.
Yeah. Let's do this. Cancel out.
H square plus 2xh.
Correct. H square plus 2.
சரி இப்போ ஒரு x ஸ்கொயருக்கு h கேன்சல் ஆயிடும் சார்.
Yes. H into 2x plus h. Correct?
எஸ் சார்.
So what is its value? You put h equal to 0. It's going to
2x.
2x, sir.
2x.
So that is the derivative of x square plus 2. Okay. So this is how you find out the derivative from the first principles of the math. இப்போ அடுத்தது, now let us see this concept of differentiability. Smooth curve நம்ம இப்ப போட்ட மாதிரி இருந்துச்சுன்னா it is okay, so it will be, we can apply this formula, but unfortunately all functions are not right? For example mod, so it will have a sharp turning, yeah. So and mari for certain functions, so the differentiability itself may not be there at some points. So if differentiability அப்படினா என்னன்னா, like we saw continuity last class நம்ம continuity பத்தி பார்த்தோம். அதே மாதிரி differentiability என்னன்னா, the derivative also you can see that when h tending to 0, it can tend to 0 from the right hand side or left hand side. So just like for limit we have the left hand limit and right hand limit, this derivative also is there on the left hand derivative and right hand derivative. Okay, so differentiability now, the left hand derivative should be equal to right hand derivative. So for that we'll have to find out the left hand derivative. So let's say left side derivative, not instead of left hand derivative, but left side be equal to right side. So this is the rule for differentiability. So we need to know how to find out the left side derivatives and right hand side derivative. So let us do a problem for this. So what is the formula for these? I'll write down the formulas. The left hand side derivative is, we call, let us say left hand side derivative equal to h tending to 0 minus Otherwise, the function remains the same. Therefore, அதே மாதிரி right side derivative, right hand side derivative, it's tending to 0 plus. So let's do a problem. Say, let us say is modulus of x minus 1. So what will be the modulus of x minus 1? It will be equal to x minus 1 when x is greater than 1, equal to minus of x minus 1 less than 1. Right? So that is the definition of modulus. So if it is negative, then we still take the positive, another, so we put negative of that. So இப்போ நம்ம right hand side derivative now, let's do left hand first. So this will be equal to, since it is on the left hand side, it is going to be minus, right? Minus x minus 1. Sorry, we use another formula. Okay. We are trying not just the modulus function, but we are trying to find it out at x equal to 1. Yeah. So at x equal to 1 அப்படிங்கும்போது, so we take it as limit x tending to 1 minus So here if you see, this is f of 1 minus f of 1 plus x divided by 1 minus 1 plus x. So this is the other way of putting. When you want to find out the limit at a particular point, this is the formula that we use. So what is f of 1? You put is 0, right? F of 1 is 0. So you put x equal to 1 and mod function becomes 0. Minus.
0.
Yeah. So f of 1 plus x is 1, right?
Yes, sir.
1.
X.
Yeah. So the left hand limit will be minus 1. See, the function is like this. Okay. x equal to 1, right? Up to 1, it goes like this. Up to 1, it goes like this. This is the modulus function. Because everywhere it has to be positive. Here, when x is negative, it takes minus of minus. So, in the Mario. So you can see that here the slope is minus 1 and here the slope is plus 1. Right? So here it is changing in a negative manner and here it is changing in a positive manner. So that is what you get. LHD is minus 1. Similarly, if we calculate RHD, it becomes so this will become plus 1. So you can see from the graph also that on the left hand side the derivative is minus 1 and right hand side the derivative is plus 1. So here, even though this function is continuous, you see that the left hand derivative is not equal to right hand derivative. The curve is, it's not a smooth curve. So இதுவரையிலும் ஒரு மாதிரி சேஞ்ச் ஆயிட்டு இருக்கு, இங்க சடனா it changes in a different manner. So இந்த மாதிரி இருந்துச்சுன்னா, so the left hand derivative and right hand derivative, they are not equal, then that function is not differentiable at this point. Here, LHD not equal to RHD. So we say that this is not differentiable at x equal to 1. So even though a function is continuous, it is not necessary that it will be differentiable. But the other way is true. If a function is differentiable, it will be continuous. Okay? But if it is continuous, it is not necessarily differentiable. Okay? So this is the concept of differentiability. So let us take another function, another example for this. So f of x equal to x when x is less than or equal to 1 and f of x equal to x square when x is greater than 1. When x is less than 1, it is equal to x. So it goes like this. Okay. So when x greater than 1, it goes like this. So x square. Goes like that. So here you can see that this curve is continuous. Okay, right? Because at x equal to 1, y is equal to 1, so it is continuous. But if you see in the rate of change ஒரு மாதிரி இருக்கு, in the rate of change வேற மாதிரி இருக்கு. So is it differentiable at this point?
No, sir.
Yeah, because
No, sir.
the rate of change is different on both sides. It is not differentiable at that point. So அதே மாதிரி நம்ம போட்டு பார்த்தோம்னா we can see that here you will get 1 on the left hand side, you will get the rate of change as 1 and right hand side you will get it as 2. So, now, let us look at some rules for differentiation. by dx of so ரெண்டு ஃபங்க்ஷன் இருக்கு f of x g of x அப்படின்னு. So suppose you want to differentiate this function, it is d by dx of f of x plus d by dx of g of x. This is rule number 1. The same thing applies for minus also. So I am not writing minus separately. So now let us look at this is called addition or subtraction rule. This is a product rule, fx into gx. This is going to be f of x into g prime of x plus g of x into f prime of x. So this is called the product rule. Other is a quotient rule. இது எப்படின்னா g of x first போட்டுக்கணும். Okay, g of x into f prime of x minus f of x into g prime of x. Divided by g of x square. This is called the quotient. There is another rule called chain rule. We will come to that. But let's do some basic problems from this. And I want to tell you some basic derivatives of some elementary functions. We already saw that, no? If f of x equal to c constant, what is its derivative?
C.
So any constant, the derivative is zero. Zero. Okay. F of x equal to, let us say, x power n. What is f prime of x?
N into x power n minus 1.
Okay. So we already saw earlier for f of x equal to x square. We saw that it comes to 2x, right? Similarly, if you put f of x equal to x cube, f prime of x will be, you put 3 and then 1 power less, 3x square. So this is your rule. F of x, if it is x power n, your f prime or derivative is n into x power n minus 1. So this applies for when n is a negative or n is fraction also. For example, let us say f of x equal to 1 by x square. So how will you differentiate it? What is its derivative?
X power minus 2.
Yes. So you have to write this as f of x equal to x power minus 2 So here the n is equal to minus 2. Okay. So you apply the same rule. So it is minus 2 x power n minus 1. Yeah, minus 2 minus 1. So that means minus 2 into x power minus 3. Or you can write it as minus 2 by x cube. Okay. Any doubt in this?
No,
No,
sir.
sir.
Clear, right? So அதே மாதிரி when f of x is n is a fraction also, so let's say square root of x, இதுக்கும் நம்ம அதே same rule we can apply. So how root of x is equal to x power half. Yeah. So here n is half. So n x power n minus 1. Correct? 1 by 2 root x.
Yes, sir.
So let us say y equal to log x. This is the next rule. So either number we seen that right in the last class. What is the limit for log 1 plus x, and all that. So using that we can derive that dy dx, if it is log x, its derivative is 1 by x. Okay. Or I'll write it as d by dx of log x equal to 1 by x. Next rule is d by dx of e power x equal to c power x. Then let's look at some of the trigonometric functions. Sin x order derivative. Does anybody know?
Cos x. Cos x. Cos x.
D cos x
Minus sin x.
minus sin x. Derivative of tan x.
Cos x.
Not cot x. So you apply the quotient rule, right? Apply the quotient rule and tell me.
Secant square x.
So what is quotient rule here? Sin x by cos x. So we write cos x into d by dx of sin x, which is again cos x.
Cos x.
Minus sin x into d by dx of cos x, which is Now the numerator is 1. This is secant square x. Okay, so other things you can derive. You don't have to remember all those things, because all you have to remember is sin x and cos x. Other things, if somebody asks you what is it for cosecant x or cot x or things like that, you can simply write it in terms of sin x and cos x. Everything, all others you can write in terms of sin x and cos x and apply this quotient rule or product rule, as the case may be. Okay. So let's do some problems to get these things clear. Let's differentiate these things. F of x equal to x minus sin x. Who can do that? What is the derivative of this? So we've seen that if it's a composite function like this, fx plus gx abina, so we can differentiate each one. So it becomes derivative of x minus derivative of sin x. So what is derivative of x?
1.
1. And derivative of sin x?
Cos x.
That's all. Now let's give another simple problem. Tell me.
Cos x minus sin x.
Yes. Very good. Let's do one more thing. So इधर भी बोलना. U
X cos x.
Yeah, U into
X plus
first the differential. First you keep x, okay, that U, and then differentiate V. X into what is the differentiation of sin x?
Cos x.
Plus second அப்படியே வச்சுக்கணும் sin x. First differentiate பண்ணணும். X differentiate பண்ண என்ன வரும்?
1.
1. அவ்வளவுதான். X into cos x plus sin x into 1. Okay, let's take f x. X cube cos x. இதே மாதிரி தான். So please do this. So first what we should do? Keep
X
just
cube.
u. Yeah, x cube. So what is the derivative of cos x?
Sin x.
Minus sin x, okay? To be careful about sign.
Both
Plus?
is there. Plus cos x.
Cos x into
1.
yeah, x cube. Yeah, 3x cube got a derivative 3x square. So yeah. So it's very easy, but you have to be careful. That's all. Let's see fx. திருப்பி சொல்லுங்க பாப்போம். Four into secant x.
4
Okay. Let's write it, one step extra here. In a secant x க்கு நமக்கு derivative தெரியாது, அதனால we can write it as 4 by cos x. tan x க்கு நம்ம முன்னாடியே பார்த்தோம் நம்ம, அதனால tan x அப்படியே போட்டுக்கலாம். So இது வந்து 4 into, okay, 1 by cos x இல்லையா, அது u by b ஃபார்முலா யூஸ் பண்ணணும். 1 by cos x ன்னு இருக்கு. So first என்ன பண்ணணும், கீழே வந்து cos square x போட்டுடணும். First எடுத்தோன்னா b, okay, cos x into du. 1 ஓட டெரிவேட்டிவ் என்ன, கான்ஸ்டன்ட் ஓட டெரிவேட்டிவ்
0
minus b into cos x ஓட டெரிவேட்டிவ். கரெக்ட்டா?
Yes, sir.
So 4 into 1 by cos x போட்டாச்சு, plus tan x க்கு secant square x. This we saw. இல்லனா இதே மாதிரி போட்டுடலாம், sin x by cos x ன்னு போட்டு we write in the same way. Four into, so this is 0. So minus 1 into minus sin x is sin x by cos square x plus secant square x. That's all. Sometimes you have to simplify it, especially if the objective type question and they may have given the answer in a particular format. You have to try to get it to that format. So இது வந்து நம்ம 4 sin x by cos x into 1 by cos x ன்னு போட்டுக்கலாம் இல்லையா. sin x by cos x என்ன, tan x. 1 by cos x வந்து secant x. இப்படி வந்துருது. So இப்ப secant x காமனா இருக்கு. So let's go. E power x into sin x.
e power x into cos x.
E power x into sin x order derivative cos x plus sin x into derivative of e power x என்ன, e power x order derivative e power x தான். Okay,
Okay, sir.
so it is going to become e power x into cos x plus sin x. Okay, let's do one more. Tan x divided by x.
x secant square x minus
X into
x secant square x minus tan x divided by x square.
x into secant square x minus tan x into 1, right? Because the derivative of x is 1 whole divided by x square. So that means x into secant square x minus tan x whole divided by x square. So இதை நம்ம வந்து இப்படி கொடுத்திருக்காங்க tan x minus 1 by secant x அப்படின்ட்டு. So there are two ways in which we can do. One is we can simplify. Tan x by secant x என்ன வரும்? Sin x by cos x. So we can write it first like this. Tan x by secant x minus 1 by secant x. So tan x by secant x என்ன? Sin x by cos x
sin x, sir.
into cos x. No, 1 by, yeah, correct. 1 by secant x is cos x. That is simply sin x, right? Minus, this is cos x.